calculator, I'm going to get very upset. Should not need a calculator whatsoever. Put it away. So today we're going over special right triangle rules. Okay? So first off here, I have a square. What do you know about a square?
4 sides.
It has 4 sides. What do we know about those sides?
90 degrees.
The sides.
They're all equal to
They're all equal to each other. Okay. So I'm going to label all 4 of these sides with that dash mark to show that they're congruent or equal to each other. Okay? Counter said they're 90 degrees. Those are the angles. I'm going to label all my angles 90 degrees. That box in the corner. All right. Don't write anything in the middle. So what I'm going to do now, I'm going to draw in a diagonal. Okay? Okay, so here's my diagonal. This is an orange pen. So when I do that, it splits it into 2 right triangles. Okay? Can you see the 2 right triangles? All right, so I want to focus, and my highlighter is really bright, so focus on this one right here. Okay, so I'm focusing on this right triangle there. Now when I drew in this diagonal, it split that 90-degree angle into 2 equal parts. Okay, so this angle here would be 45 degrees, and this angle up here would be 45 degrees. All right, from here I'm going to label my right triangle. So opposite that 90-degree angle, that side, is the hypotenuse. Okay, and the other 2 sides are your legs, right? So we have one leg here and one leg here. Now what I want to do is kind of derive the formula that we're going to use today. So if I label one leg as x, the other leg has to also be x, right? Because we said this was a square and we labeled those sides congruent. Okay, so both of those legs I'm going to label as x. So I'm going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. Now c squared again is always your hypotenuse. Okay, the other 2 sides are a and b. So I'm going to plug in x for a. So we have x squared plus b is also x, so we also have x squared is equal to your hypotenuse squared. So I'm going to write hypotenuse and squared. And I'm going to abbreviate it because I don't want to write the whole thing. Relax, you'll understand why. So from here, I'm going to combine like terms. So if I have x squared plus x squared, that's 2x squared, which is equal to the hypotenuse squared. All right, so at this point, you usually kind of divide by 2, but I'm not going to divide by 2. I'm going to take the square root of both sides. Okay, I'm taking the square root of both sides. When I do that, I still have this square root of 2 multiplied by, if I take the square root of x squared, that's just x, is equal to, if I take the square root of the hypotenuse squared, it's just the hypotenuse. Now what did I label x as in my triangle? What was that? A leg. So I can take the square root of 2, multiply it by the length of the leg, and it will give me the hypotenuse. That's the rule that we're going to use today. Okay? So that is the rule for a 45, 45, 90 right triangle. So when you're looking at these special right triangles, you always want to look at the angles first to make sure it's a special right triangle. So for a 45, 45, 90, your legs are congruent and your hypotenuse is equal to a leg times the square root of 2. So I'm just going to rewrite our formulas over here. So if I'm trying to find the hypotenuse, that will be equal to the square root of 2 times the length of a leg. Now if I'm trying to find a leg, and I'm given the hypotenuse, your leg will be equal to the hypotenuse divided by the square root of 2. Now when we did that radical review before, and we had a radical in the denominator, we had to simplify that. Okay, so if this happens, you need to simplify. So you need to multiply by that version of 1. So you're multiplying by square root of 2 over square root of 2. Okay? So we're going to go through an example. So number 1, we want to find the value of x. First thing I do is look at the angles. Okay? This is a 45, 45, 90 right triangle. So I can use these rules over here. Next, I want to label my sides. So opposite that 90-degree angle is your hypotenuse. That means the other two sides are your legs. Okay? So the other two sides are your legs. Now, since I'm looking for the hypotenuse, I'm going to go to the equation that says hypotenuse equals. Okay? I'm looking for the hypotenuse, so hypotenuse equals. And I'm going to plug in what I know. So the hypotenuse is x. Then I have equals the square root of 2 times a leg. Well, the leg is 6. Okay? I'm just going to rewrite this. So x will equal 6 times the square root of 2. That's your answer. You're done. Okay? No. Yes.
Wait, yes?
Yeah.
You just said no.
I said yes.
She said yes to me. Oh my gosh, in my calculator.
Don't put it in your calculator.
Yeah.
So, number 2, we're going to do the same thing. Now, in this one, it didn't show you the angles. However, if you look at the sides of this triangle, they're equal. Okay? That means these two angles are equal, and they'd have to be 45. Okay? So, this is still a 45, 45, 90 right triangle. So, from here, I'm going to label my sides. Opposite that 90-degree angle is the hypotenuse. Your other two sides then are the legs. Okay? My x value is where I labeled hypotenuse. So again, I'm looking for the hypotenuse. Okay, so I want to go to the equation that says hypotenuse equals. And plug in what I know. So for hypotenuse, that's x. Then we have is equal to the square root of 2 times the value of your leg, which is 9, times the square root of 2. Now if I multiply the square root of 2 times the square root of 2, what do I get? The square root of 4. What is the square root of 4? 2. So I end up with 2 times 9. So x will be equal to 18. Do number 3.
Yeah.
All right, so looking at 3. We have a 45, 45, 90 right triangle. Opposite that 90-degree angle is the hypotenuse. The other two sides are your legs. Again, my x value is where I labeled the hypotenuse. So I'm going to use this equation here because I want to find the hypotenuse since that is what x is. So I'm going to plug in what I know. The hypotenuse is x. I have equal to the square root of 2 times the value of the leg. The leg is 4. And I'm just going to rewrite it. You don't have to. You can honestly just leave it like this and circle it if you want. So x is equal to 4 times the square root of 2. Good. I'm glad. Any questions on that type? All right, number 4. This is supposed to be an x. So you know that the sides are the same. Okay? Since the sides are the same, that means your two angles are going to be the same, so they have to be 45. So again, this is a 45, 45, 90. Opposite 90-degree angle is your hypotenuse. The other two sides are your legs. Now this time, x is what one of the legs is. So this time I'm going to use this equation because I'm finding a leg. Okay, so I'm solving for a leg. So again, I'm going to plug in what I know. So your leg is x. That's equal to the hypotenuse. Well, I labeled my hypotenuse as 5 times the square root of 2. Okay, that's over the square root of 2. Now, if I have the square root of 2 over the square root of 2, what happens?
They cancel out.
They cancel out.
You're right.
So in this case, x will be equal to 5. In number 5, again, I have two x values here. They're the same. So this is a 45, 45, 90 right triangle. Opposite the 90-degree angle is your hypotenuse. The other two sides are your legs. So again, x is a leg, so I'm finding a leg, so I'm going to use this equation here and plug in what I know. So leg is x. That's equal to the hypotenuse. Hypotenuse is 12 over the square root of 2. Now I need to simplify this. So you need to multiply by that version of 1. In this case, you're multiplying by the square root of 2 over the square root of 2. Okay, you multiply straight across. So we have 12 times the square root of 2 over, I have square root of 2 times square root of 2, square root of 4, right? And that is 2. I can simplify my numbers here. I have 12 over 2. So that is 6 times the square root of 2. And that would be your answer. Okay, so honestly, you're just plugging these in. Now, if you don't always have your note sheet handy for these equations, they're on these yellow and pink sheets up here. So the pink one is your 45, 45, 90 triangle. Right here you have your sides. You have two the same and one where you have the leg times the square root of 2 for your hypotenuse. Okay? So your equation is up here. Now on the back, we're going to go over 30, 60, 90. Okay? So on the back here, I have an equilateral triangle. Okay? What do you know about an equilateral triangle? Anything? Do we know anything about an equilateral triangle?
All sides are the same length.
All sides are the same length.
Sir.
Okay, so I'm going to label those with those little dash marks, showing that they're the same or congruent. What else? Do we know anything else about an equilateral triangle besides the sides? It's not 30, 60, 90. In an equilateral triangle, I know we haven't gone over this yet in geometry, so I'm just going to tell you. Equilateral triangle, all your angles are the same. Okay? All of your angles are congruent or the same, meaning they're all going to be 60 degrees. Okay, so all three of those angles are 60 degrees. Now, I'm going to draw an altitude straight down the middle of my triangle. Okay, so from the top, straight down. It's a little crooked, but that's okay. Now when I do that, since it is an altitude, it creates this 90-degree angle here. Okay, it also splits this angle in half. So this angle over here will be 30. So now I'm going to look at this right triangle that I just formed. Right here. So this is the triangle I'm focusing on now. So just like we did with the square on the front, I'm going to label the sides. So opposite that 90-degree angle is your hypotenuse. Now with a 30, 60, 90 right triangle, we have a long side and a short side. Okay? Your short side is going to be opposite your 30-degree angle. Okay, so over here will be your short side. Your long side is opposite the 60-degree angle. Now I know the hypotenuse is the longest side, but it's already labeled as the hypotenuse. So that side opposite the 60-degree angle will be the long side. Alright, so now I'm going to label this short side here as X. Just like we did on the front, we're labeling sides. I'm going to label the short side as X. Now I'm going to label the long side as Y. Okay, they're not the same length. They are different lengths. So I'm going to label the short side as X, long side as Y. And again, I'm going to use the Pythagorean theorem. Okay, so here we're using A squared plus B squared is equal to C squared. Now this one has a few more steps, so don't write super big. And I'm going to plug in how I labeled down here. So my C value is the hypotenuse. A and B are the short and long side. So for A, I'm going to write X squared plus the other leg there is Y. So I have Y squared. And that is equal to the hypotenuse squared. And I'm just going to write hypotenuse for now. So I can't really combine anything, right? Like last time I could combine those X squared values. But if I dropped this altitude here, it splits that side in half. So if this side that I labeled the short side is X, that means it's the short side over here, meaning this is X as well, right? So what would this entire side length be in terms of X? I have an X and an X, so that entire side would be 2X. I add X plus X, I get 2X. So the entire side is 2X. Now when I labeled my equilateral triangle, all three of those sides were congruent, right? So if this side is 2X, what's this side? 2X. Okay, so your hypotenuse here is also 2x. So instead of the hypotenuse, I can plug in 2x. So now I have x squared plus y squared is equal to 2x squared. So I have x squared plus y squared. I need to distribute my squares since they are multiplied together. So I have 4x squared. Now I want to combine like terms. So I'm going to subtract x squared from both sides. So I have y squared is equal to 3x squared. Now I want y by itself. So I'm going to take the square root of both sides. So I end up with y is equal to the square root of 3 times x. Now I labeled my long side as y. So I'm going to replace y with the long side. That is equal to the square root of 3 times x was the short side, or times the short side. So this is the rule we're going to use. So your long side in that right triangle will be the square root of 3 times the short side. Okay, so 30, 60, 90 triangles are special right triangles. Our rules for them are right here. There are 4. So if you're looking for the hypotenuse, it is equal to 2 times the short side. Now, if you're looking for the short side, you could also take the hypotenuse and divide it by 2. My other equation here, if I'm looking for the long side, that's equal to the short side times the square root of 3. That's what we found right here. Okay? So long side is equal to the short side times the square root of 3. And if I'm looking for the short side again, I could take the long side and divide it by the square root of 3. And again, here has a radical in the denominator, so we need to simplify. Now when you're doing these problems, if you're not given the short side, you always want to find the short side first. Okay? There are 2 different equations to find the short side. So you need to determine which one to use. If you're given the hypotenuse, you'll use this one. If you're given the long side, you'll use this one. Okay? So you always want to find that short side first because you can't find the other side unless you have that short side. Okay? So we're going to go through a few examples here. So in number 6, this is a 30, 60, 90 right triangle. Opposite the 90-degree angle is your hypotenuse. Opposite your 60-degree angle is your long side. Opposite the 30-degree angle is your short side. Please label your triangle so you don't get lost. Okay, so from here, I'm already given the long side. However, I'm not given the short side, so that's what I want to find first. Okay, so again, I have 2 equations for short side. If I use the top one, I don't have the hypotenuse. So I'm going to use the bottom one here because I have the long side. Okay, so from here I'm going to plug in just like we did on the front. Your short side is x. That is equal to the long side, 15 over square root of 3. So I want to simplify. Yes, you're correct. I'm going to multiply by the square root of 3 over the square root of 3. Multiply straight across. So we have 15 times the square root of 3 over 3. I can reduce this fraction. So 15 divided by 3 is 5. So my x value, or short side, is equal to 5 times the square root of 3. Next, I need to find the hypotenuse still. That's your y value. So hypotenuse is equal to 2 times the short side. So plugging in, y is equal to 2 times our short side we just found is 5 times the square root of 3. So y will be equal to 10 times the square root of 3. Skip down to number 10. No, I'm going to do one more. We're running a little off schedule. No, we're not. All right, number 7. We're going to do the same process. Okay, this is a 30, 60, 90 right triangle opposite your 90-degree angle. That is the hypotenuse. Opposite the 30-degree angle is the short side. Opposite the 60 is the long side. I'm not given the short side. I need to find it first. Okay, so looking at my two equations. This one, I need the hypotenuse. Oh, I don't have that one. Sorry. This one, I'm given the hypotenuse. I don't have that. So that means I need to look at this one. Am I given the long side? Yes. So I can use this equation here. So plugging in what I know, short is x. That's equal to the long side, 12, divided by the square root of 3. Again, we don't want that radical in the denominator, so we're multiplying by square root of 3 over square root of 3. Multiply straight across. We have 12 times the square root of 3 over 3, which will end up as 4 square roots of 3.
The answer is 18.
Thank you. For the hypotenuse, or y, we're going to use this equation here because we're looking for hypotenuse equals. So plugging in what we know, y is equal to 2 times our short side, which we just found is 4 times the square root of 3. I can multiply together 2 and 4. That'll be 8 square roots of 3, and that's your final answer there. Questions? All right, I want you guys to do number 8. Come on, do number 8. It's not. It's almost easier than last week.
So it's 10 over 2, so it's 5.
Yeah, that's it. I told you.
That's it?
No.
That's it?
It's going reverse, right? So y equals, I actually 5 y equals.
Can I go to the bathroom now? It's like right there. Yeah, I'll follow. Okay, so, find something. No. I feel like minute two is so much easier than one. That's easy. I'm on. Yeah, me neither. The other game yet. Lexi draws, I don't know. She's gotta go to the game too. What are you doing? Why? Because you're so annoying. I did it. Oh my god. You didn't want that.
No.
Do you have a nail file?
No. No, I need to finish going through this.
Oh, you're still moving stuff?
Yep. All right, so for number 8, 10 is your hypotenuse. Please label your sides, okay? Just label them so you know which side is which. 10 is your hypotenuse. X is your short side. Y is your long side. Okay, finding the short side. I'm going to use this equation here because I'm given the hypotenuse. Okay, so here I'll have I'll have x is equal to, the hypotenuse is 10 over 2. So x is equal to 5. For your long side, you're going to use this equation here. So long side is equal to short times the square root of 3. So long side is y. That's equal to your short side, which we found is 5, times the square root of 3. And that would be your answer. Okay, so again, you're just plugging it in for that equation. Any questions? All right, in your groups, talk about why are some right triangles considered special? We just talked about 2 special right triangles in your groups. Why are some considered special?
No, I didn't mean to, no. Didn't mean that.
Good, you want a piece of my hair? It's all
Yeah, the answer is right. I give the answer. Get that. Oh my gosh. Oh shoot. Oh.
I don't know, you supposed
All right, anybody want to tell me why some triangles are considered special? Because they look special?
No, it just matters.
What did I tell you at the very beginning of class to put away? A calculator.
Because we
Okay?
have to use a calculator.
Because you don't have to use a calculator to find the sides of the triangle. Okay? So once you identify
Okay, but what if it's a
that
big number?
a right triangle is special, you can solve the triangle without use of a calculator. Okay? So even if you do have some bigger numbers, you shouldn't need a calculator because you're not simplifying the radical. Your radical is either going to be the square root of 2 or the square root of 3. Any questions on special right triangles?